In Java, there are two ways to pass objects to methods. The first one is by value. The second one is by reference, or commonly known as passing by value for reference type value. We'll look at these two use cases. There's also generally two types of object. One of them is the primitive type, like your normal integer, double, boolean, etc. There's also wrapper type objects or custom object that you created or instantiated based on your class. The former type object passes their value into the methods, whereas the second type, these wrapper class instantiated objects, they pass by reference, or the value of the reference for that object being passed. Let's look at these examples next. In Java, you can pass objects as arguments to methods like you pass primitive data types. When you pass an object to a method, like your object circle C, like your object myCircle, these are dynamic objects created in a heap. And this is assuming myCircle is of type circle and instantiated as new circle. Same thing with C, instantiated as new circle. This places their reference objects, C and myCircle, both in the heap portion of your memory. These two objects are dynamically allocated. When you pass an object to a method, you're passing a reference to the object. That reference stores the memory address of your circle object. There's two objects being created. C points to one area of your heap. myCircle points to another area of your heap. One of them, say, has memory address of 1. The other one has, say, memory address of 2. Your reference for myCircle points to this, address 2. Your reference to the first created circle points to address 1. This means the method receives a copy of the reference to the same object in memory, not a copy of the object itself. As a result, any changes made to the object within the same method will affect the original object outside the method. On the other hand, if you have primitive and you're passing that primitive to a method, that primitive should have a value, let's say integer 5. What you're passing into that method via this times variable, which is an integer primitive, is basically 5. There is no external referencing with primitives. You're passing by value. In a lot of textbooks, you'll see pass by reference in Java. What actually happens is you're passing by value. Here, the value is the reference for the object. Or sometimes people say pass by value of the reference. So what is the reference? Reference is an integer memory address of that remote object you're referencing. The value of the reference is basically a copy of that memory address. But ultimately, that memory address still points to the object. Hope that makes sense. So instead of saying pass by reference, the correct way of indicating what Java is doing by passing object to method, it is pass by the value of the reference. In your textbook, it says pass by value, but making sure that this pass by value is not the same as pass by value here for the primitives. This demonstrates how you can pass object to methods in Java and modify their state within the methods. In other words, if I were to change this object right here with address 2 that is referenced by your myCircle, inside the calling methods where this myCircle is, you'll see the change that was just made here. And notice another thing. When you declare your circle or even these primitives, they're inside what's called stack memory. This is a very small amount of memory space compared to heap. Heap is for dynamically allocated objects, whereas stack is what they call for statically declare. This static is not the same as the keyword static. This just means that when you declare circle C, for example, or even myCircle, only declaration, there is no dynamic memory allocation. C and myCircle sits inside stack, but both should have a reference to this dynamically created objects inside your code, where C and myCircle will eventually be the references for the actual objects in heap with their memory address. So when you pass C and myCircle to a method, you're passing by the value of the reference it points to inside the heap. Reference is synonymous to memory address. In other languages like C++, there's actually a difference between reference and memory address. But for now, just remember reference is synonymous to memory address.